Okay, so the next thing that we need to do here, these actually, the width is properly sized right now. And now we have to actually take some material out. Oops, if I did it straight. We have to take some off of the top. So these end up being 5/8 of an inch wide by 1/2 inch tall. Now they get attached to the vertical supports with some screws here, okay? And I think what we're going to do is to, in light of the effort that we went through to get these, the screwing around we did with that, I'm going to utilize these screws to help me fixture this for the next machining operation. I'm just going to take a piece of steel here, and it's going to become my machining fixture. So what we'll do first is drill and tap some holes in this, and then we'll punch holes in that, and then we'll just attach these to the top, and then we'll deck them off, and then we can remove the screws, and they'll be our fixturing items. Okay, so I think that's the plan, and so let's get this thing in order here. We'll just deck this off so it's nice and flat, drill and tap some holes, and Bob's your uncle. Okay. All right, here's one of these situations, right? So we got several parts to drill and counterbore, okay? And so we can drill, and drill, counterbore. Or what we can do in this case, it's an easy part swap. So what we're going to do is we're going to drill the first hole in all of them. Okay, I'll swap the part out, like I said, because it's an easy swap. Okay, easy in and easy out. Okay, and then drill the next one. Then I'll move down to the next location and I'll do the same thing there. And the reason is there's a large distance between the holes, right? So there's a bunch of cranking and then you have to do a precision stop here. So it's a lot easier to get on the number once, drill, swap the part. Now this works great when the part's easy to change. If you have a very tricky setup, then it's not worth it. Or if you only have one part, it's obviously not worth it, right? But if you have a few parts and a couple holes in each part, if you have a long distance to move or a lot of holes, then a lot of times it makes more sense to swap the part than it does to do the move on each one. I hope that makes sense. So let's go ahead and pop some holes. Okay. You see, I'm supported underneath close to where I'm drilling there. Okay. All right, so we got our little machining fixture set up here, and we're gonna clamp these little monkeys down here. So I'm just holding it down with some machine screws here. Now, this is kind of an interesting mental exercise. So I'll run these down. So, you know, how well are these screws holding this down, right? That's the question. So what we're gonna do, we're gonna snug these down a little bit. And these are more than adequate, you know, and that's based on experience with this kind of stuff. So what we're gonna do, just for fun here, is I'm gonna use a torque wrench here, okay? And we're actually gonna torque these down. And I'm gonna give the viewership out there, I'm gonna give you guys a little homework assignment. And your homework assignment is to figure out how much clamping load that we're inducing on this part. How hard are we holding this down? We got 3 points here, and we'll just consider one of these, okay? And you know, so what is the clamping load? And I'm just going to bring them up to the final torque in a couple of increments here. And I'm going to put all the specs on the screen for you guys, okay? And you guys will figure it out. Okay, and the first person that correctly gives me the clamping load, all right. Let's see, hold on a sec. Where's my little thing? So what I've done is I've written down the answer here, and we'll open this up on camera and we'll announce the winner in the next video. Okay, so we're going to torque these down. All right, here's the torque specs, here's the fastener specs right on the screen. Pause the video. All right, so we're taking these to 90 inch-pounds, okay. Each fastener 90 inch-pounds. Okay, all right, and they're number 10 screws, which are 190 diameter, roughly 4.8 millimeter diameter, and we're torquing them to 10.2 Newton meters, okay, or 90 inch-pounds. And like I said, I've written the answer on this, and put your guess in the comments, and first person to get the correct answer gets some Ox Tools swag, okay? I'll set that aside. Now let's do some machining. So one of the, somebody put up a question about my choice in cutters when we were doing the side surfaces on these things, okay? So, there's a reason for everything in this work, sometimes. So somebody suggested, why didn't I fly cut that, okay, with a little fly cutter like this, okay? Or a big one when I had all these bars clamped together. Well, there's a couple reasons. One is, this is a single lip cutter, okay? So its chip load is 1 tooth, okay? So to balance that chip load, you have to feed it at a rate that this 1 tooth can handle. Now, as soon as you increase the number of teeth, cutting teeth, with the same chip load, this is going twice as fast, and so on and so on. And that's a 5 flute cutter there that's going, okay? And it's leaving a beautiful finish, by the way. So with this, I'd have to feed slower to get the same finish, okay? Yeah, okay, I might be able to cover that full width, okay, but I'm going to be feeding slower. So it's this one, I can feed faster with the same chip load because I can run it faster, and I can feed it faster too, so because this is carbide as well. So you kind of balance those things out, right? So old school is not necessarily always the best choice, right? This cutter is highly effective, and until you've tried one of these, this new stuff comes along, yeah, you should try it, because I haven't used these in years, literally, because of this, and because it works so much better. And it produces better finishes, more consistent results, less tool breakdown, less tool fussing. I have to fuss with this edge to get a really nice finish. It's totally doable, but yeah, if you're on a limited budget, this is a great choice, okay? This is a great investment if you want to invest in a tool that will work for a lot of different stuff, okay? This is an AB Tools shear hog. And this is just an absolute wonderful tool. I discovered these 20 years ago or whatever it was and haven't looked back. Okay? So I just want to address that. Oop. Of course. Sweet.